So in this video, we're going to have a look at the gamma function. Now the input for the gamma function here, I've got gamma of x, where x is a natural number. That equals x minus 1 factorial. So reduce that by 1 to get the factorial. So for example, if x is 6, gamma of x represents 5 factorial. Now it's also represented in the integral here, from 0 to infinity, e to the minus t, t to the power of that x, which is the input, minus 1 dt. T is our dummy variable for our integral. And of course x is in the natural numbers for the integral as well. Now another property of that, if I want to get x factorial, I need to multiply that by x. So I need x times x minus 1 factorial. So that will give me x factorial. So then if I multiply this by x, I can also multiply this by x. So I've now got x gamma of x. So basically I've multiplied everything by x on each side of the equation. So that's all valid. But I've also got here x factorial. So basically added 1 to this. So we can say that that is also equal to gamma of x plus 1. So that is my claim that this and this are actually the same input. Now what I want to try and do is by using integration to show that these are actually the same. So that and that are the same. That's my claim. And then by these factorial values, I should be right. Okay, so what I can do is, let's go through the integral representation of this and let's see if I can get this. So let's have a look at what happens to this. So I've got 0 to infinity, e to the minus t. Now the input for my gamma function should be whatever is in this red bit here. So that x and that x should be the same. So now I've got t to the x. So here I want x plus 1 to make this. So I want x plus 1 and then minus 1 and then dt. Okay, now need to integrate this. Well, first of all, what I can do is I can just simplify this off a little bit. So rewrite the integral from 0 to infinity, e to the minus t, and t, well, x plus 1 minus 1 is just x. And then that's dt. Okay, now to integrate this, I've got my parameters of integration. We can integrate this, and I've got integration by parts because I've got two functions here. So I need to work out which I'm going to take the derivative of and which I'm going to integrate. So this looks like the best chance to use with a derivative. So integration by parts. My formula for that is the integral of u dv. That equals uv minus the integral of v and du. So uv is part of my answer, and v and du then forms another integral. That's how integration by parts work. So one of my inputs is going to be my u. The other input is going to be dv. The dv is the one that I'm going to integrate because my u here is just repeated and I've got a derivative here. So I'm going to let t to the x be my u. So if u equals t to the x, then my du, take the derivative of that with respect to t, I've then got x times t to the x minus 1. So that's using the power rule for derivatives. So therefore my dv, that's going to be e to the minus t. So then if I integrate that, my v then becomes minus e to the minus t. So that's my integral with respect to t. So that's my building blocks for my integration by parts. So then what I need to do now is this integral now equals, so I bring this down and that equals u times v. So t to the x minus e to the minus t. So if I just write that in a bracket, because that will be under the parameters of integration. So t to the power of x, e to the minus t, and the minus sign I'll just bring to the front. And then the parameters of integration count for this because this is part of my answer. So I've got 0 to infinity. And then I subtract the new integral, v, which is minus e to the minus t. So I've got minus e to the minus t. And then du, which is xt to the x minus 1. So xt to the x minus 1 dt. And that's also from 0 to infinity. Okay, so what have we got here? So let's calculate what happens when t is infinity. Well, if t is infinity here, this will approach negative infinity. But if t approaches infinity here, this will approach 0. So the value at infinity is 0. What about when I've got 0? Well, if t is 0, that just becomes 0, and whatever that is not even a problem, because that's going to be 0. It's going to be 1. E to the 0 is 1. But that's 0. So I've got 0 minus 0 situation. So that all cancels out. So that cancels. So that's good news. Now let's simplify this. So I've got minus and a minus. So that becomes positive. I've got 0 to infinity. So that's fine. Now I'm integrating with respect to t. So this has got a t in it, this has got a t in it, but this is just x. So that can come out to the front. So now I've got an x there. And then I've got left e to the minus t and t to the x minus 1 dt. Well, I know this is my standard integral that I've got here. So this bit here, that's my standard integral for gamma of x. So if I multiply that by x, I've got x gamma x. So x gamma of x. And my claim is that x gamma of x equals gamma of x plus 1. So by inputting x plus 1 into here, I then get x gamma of x. So therefore that equals gamma of x plus 1. So by integrating, I've just shown that they are one and the same thing. Okay, that's all good. So let's put a circle around that. We've just shown that by integration, and there we go.